The Tesla Model 2 is engineered to transform short city drives into an enjoyable, confident, and surprisingly premium experience for its price class. Its design goes beyond simple transportation, focusing on a cabin that acts as a single interconnected system where every surface, cushion, and support zone adapts to real human behavior. The core question driving this design was radical for a compact EV. How can a cabin learn to anticipate subtle shifts in posture, pressure, and movement for adults, children, and families simultaneously, potentially resulting in the most inclusive and comfortable cabin ever built in an affordable electric car? Tesla's team redesigned the entire seating ecosystem before designing any individual seat, approaching the cabin like an interconnected biological system, similar to how SpaceX engineers design crew capsules where every surface influences posture and stability. The foundational process involved biometric mapping of over 30,000 users of various ages, body proportions, and driving preferences. This monitoring tracked real micro-movements during daily commutes, such as slight shoulder shifts, foot repositioning after traffic lights, how passengers brace during lane changes, and children's natural leaning during naps. This extensive data revealed that comfort is defined not just by softness or padding, but by how the cabin anticipates and reacts to these microbehaviors. For instance, adults rotate their hips by $2 to $5 after 30 minutes of sitting. Children's shoulder alignment changes as they grow, and older passengers rely heavily on grip points when entering or exiting. Utilizing this insight, Tesla created a dynamic seating ecosystem where each row supports the others. Seat heights were staggered to maintain sight lines and minimize motion sickness. Cushion densities across the cabin were tuned to ensure that pressure transfer during braking or acceleration feels consistent, eliminating the seesaw effect often found in compact electric cars. Even the vehicle floor incline, a typically overlooked component, was modeled to aid in maintaining healthy circulation during extended trips. SpaceX-inspired engineering influenced not the seats themselves, but the structural shell of the cabin's ability to absorb vibration. Instead of individually reinforcing each seat, Tesla developed a continuous energy dissipation path located under the floor rails. This path reduces vertical vibration by $12% to $18% before it even reaches the cushion, a concept akin to how SpaceX distributes launch vibration across a capsule frame, rather than relying on heavy shock absorbers beneath each astronaut. Consequently, every seat in the Model 2, including the driver's seat, passenger seat, rear bench, and integrated child seat, is optimized to support the overall ecosystem, leading to smoother and more intuitive transitions between different seating types. This overarching design philosophy ensures that subsequent seat-specific innovations feel cohesive rather than isolated. The Model 2 driver's seat incorporates SpaceX-inspired principles for both comfort and durability. It is approximately $6 to $8 wider than the Model 3, increasing from 55 centimeters to about 58 centimeters. This expansion is based on anthropometric data from millions of middle-aged American drivers, a group frequently reporting back pain or leg numbness during long drives. The larger contact surface more evenly distributes force, significantly reducing concentrated pressure on the spine. Simulations show a pressure distribution reduction of $20 to $25 during drives exceeding 2 hours. Key dimensions achieving this include a backrest height of approximately 65 centimeters and a cushion thickness of 7 centimeters, preventing weight from focusing on the lumbar region. For drivers taller than 1.75 m, the thigh cushion extends an additional 2 to 3 centimeters to improve blood circulation, with Tesla recommending a specific 2 to 3 centimeters distance between the cushion edge and the knees to avoid thigh numbness. For stability during rapid response situations, the seat frame uses a side-reinforced structure with high-strength steel. Lateral load simulations indicate this frame increases strength by about $15 during sudden steering maneuvers, maintaining driver stability and improving steering precision. The seat adjustment system is minimalist, retaining only essential directions: a $25 cm sliding range, a $15 /circ backrest tilt, and a $5 cm thigh cushion lift, which is adequate for most adults to find a natural position without excessive manipulation. The seat band is positioned 40 centimeters from the floor, 3 to 4 centimeters lower than a standard seat, which reduces knee strain by up to $30 during entry and exit. In terms of long-term durability, the synthetic leather is reinforced with thin ceramic fibers, a heat-resistant material used in rocket equipment protection. This material ensures the surface resists cracking or fading after years of strong sunlight, maintaining durability and color when exposed to temperatures up to 120 carat/circ$C. Beneath the leather is a 2-layer foam system, a firm load-bearing layer and a slow rebound memory foam layer. Compression cycle tests show this foam retains its form after more than 100,000 sit and stand cycles, equating to over 8 years of average use. The surface also features light friction to prevent sliding during quick acceleration, 0 to $100 km/h in about 6.5 seconds, and small ventilation holes prevent back overheating on long trips. The Model 2 front passenger seat is designed to offer a private, comfortable space, not merely a ride-along position. The design team prioritized an airy feel. The seat width is intentionally $56 cm, slightly narrower than the driver's seat by about $5 to allow extra hip space for natural entry and exit in tight parking. Legroom is emphasized with a depth of $102 cm, 5 centimeters longer than the driver's seat due to the absence of the steering wheel. The $50 cm distance to the dashboard is about $10 larger than most small EVs, creating an expanded sense of space. SpaceX inspiration is evident in the backrest tilt of $2 carat/circ$ to $4 carat/circ$, which mimics the posture of astronauts during rocket landing, naturally distributing force across the back and shoulders. A soft landing mechanism, functioning like the shock-absorbing pistons on the Falcon 9 landing legs, reduces vibrations by about $20 over rough roads. The $30 cm sliding range allows precise adjustment, similar to how astronauts refine seating positions to prevent fatigue. Materials include a hybrid surface of synthetic leather and breathable mesh, which improves airflow by about $25 for immediate comfort on hot days. Inside, 2 foam layers are used, a firm lower layer for torsion support and a soft upper layer for cushioning. The seat cushion has undergone 100,000 compression cycles to prevent permanent sagging, and a nano-dust-resistant coating allows the entire surface to be cleaned in about 5 minutes. The rear seats of the 2026 Tesla Model 2 meet the challenging requirement of comfortably accommodating 3 adults without shoulder collisions or cramped knees. The bench width is expanded to approximately $140 to $145 cm, exceeding most small EVs by $3 to $5 A backrest height of 63 centimeters provides better head and neck support for trips over 2 hours. The completely flat floor, which is unusual for the segment, and the absence of drivetrain hump, raise leg height by about 5 centimeters, improving posture and facilitating easier entry and exit for adults and children.